Today we'll be talking about a box on an inclined plane. So first of all, we'll draw a right angle triangle, which is our plane. We'll have some theta and our box. So the first thing to do is draw all your vectors. You're going to have your force of gravity, your normal force, and I'll be including a frictional force. That's F of F. Now, I'll give you, there are some givens, so some knowns. So we know the mass of the box is equal to 4 kilograms. We know that the coefficient of friction is equal to 0.8. Now remember, that doesn't have any units. We know that theta is equal to 60 degrees, and we're asked to solve for acceleration. A few things we should do first is to separate the force of gravity into two components. So we'll draw our F perpendicular and F parallel. Now, an easier way to represent that, here I'll just draw it on the side. So it's another right angle triangle, and this is our F of G. This is our F perpendicular. This is our F parallel. And it's interesting to know that theta actually appears in this triangle as well. So it makes calculating the F perpendicular and the F parallel super easy. So we can write that F perpendicular is equal to FG cos theta, and F parallel is equal to FG sine theta. So this is just a few equations we can write down that we know and we can solve for. And first of all, to find the acceleration, we obviously need to know the net force. So we have F net is equal to ma, and that a is the acceleration we're looking for. So all we have to do is find the sum of the forces, and we know our m, and we can find our acceleration. So we know that Fn and F perpendicular, so these forces here, have to equal each other, but they're in opposite directions. And that is because the box doesn't fly off the surface and it doesn't fall through the surface. And then we know that F net has to equal the sum of F parallel and the force of friction. So we have that F net is equal to force of friction plus F parallel. So what is F parallel? F parallel, like we said earlier, is equal to FG sine theta. Just make sure here. Yep. So what is FG? FG is equal to ma, and in our case, a, the acceleration, is due to gravity. So we have a variable for that. It's mg. And then we have sine theta. So m we know is 4. G is 9.81 meters per second squared, but we're going to, sorry, that's kilograms. But we're just going to say that it's 10 meters per second squared, just so that we can simplify the math a bit. Then we have sine of 60. And then that is 40 newtons times sine of 60, which is 0.866. And this equals 34.64 newtons, which is F parallel. So this is very important. Our next force we need to find is the force of friction, which we know is equal to coefficient of friction times the normal force. Now, what is the normal force? Well, earlier we said that the normal force has to equal the F perpendicular. So we know that it's coefficient of friction times F perpendicular. And then we also know that F perpendicular is Fg, it's the opposite of F parallel, so it would be cos theta. So we have a very simple equation, so we can write that F of F is equal to 0.8, which is coefficient of friction, times F of G, which is 40 newtons, times the cos of 60 degrees. Cos of 60 is just 0.5, so we can write force of friction is equal to 0.5 times 40, which is 20, so we have 0.8 times 20, which ends up being 16 newtons. So, F net is equal to MA, which is equal to force of friction plus force parallel. So we'll just write force of friction, let's go back and find it, is 16 newtons. So we have 16 newtons. And then F parallel is 34.64. So we have minus 34.64 newtons. So this equals 18.64 newtons. Now we have to remember is that this turns out to be a negative number, but honestly it doesn't matter. All we're looking for is the direction of the force of friction and the force of parallel. So you can see here that F parallel is going this way and the force of friction is going this way. So obviously you're not going to add those vectors, you're going to subtract them from each other. And we just want to know the acceleration. We don't necessarily want to know what direction it's going in. So we know that this is equal to MA. We know that M is 4, so A is equal to 18.64 newtons divided by 4 kilograms, which is equal to 4.66 meters per second squared. And that is the final answer to the acceleration